So thanks, guys. So I mean, everybody can start thinking about your questions. So just want to kick off. I guess we touched in some of the presentations on LTS, and we saw some results from the survey about what versions of DPDK people were using. And I think maybe John was thinking that a lot of the developers had answered, and it was very skewed to the newest release. So I wanted to ask you guys, what DPDK versions do you use, and how do you handle upgrades? Do you keep up with the latest DPDK, or do you stick on an LTS, and how you handle upgrades? So,
I guess I'll start from the OVS side. So my preference is to always stick on an LTS. That's not always the case. I mean, there's sometimes reasons to migrate. Some new feature, will make us move. But if we do, I know DPDK does have something they call like a stable branch. So we'll move to whatever stable. But yeah, from the DPDK side, I like to stick on LTS. I know it's getting backports. I know it's getting support. And yeah.
I think it's good because we have a lot of hardware capabilities coming in the platform, and DPDK has been fast enough to adopt those. So I think it's a good idea to move to the latest DPDK if it works okay.
So you're always moving. You never stick on an LTS.
Yeah.
Okay.
As for my side, I mean, we are always pushing more and more features to DPDK, so we are encouraging everybody to come aboard with the latest version.
Sure. I mean, I guess an issue from a distro perspective is that, if upgrade is difficult for users, potentially, we can't. It's hard for us to release support multiple versions of DPDK. So if there's maybe one version, if there's one version of the DPDK standalone, and maybe there's 3 versions of OVS which all have different DPDKs, it makes it a little bit harder. Whereas with an LTS with backport support and maybe an LTS in a few different versions, it makes it much easier from distro perspective. Okay, thanks. So welcome, Ben. So I guess you've been involved in vSwitches for longer than most people here. So I'm just wondering what your perspective and your take of DPDK, being used as a technology in vSwitches. We've seen it across not just Open vSwitch, but multiple vSwitches.
So my perspective on DPDK is maybe kind of a historical one. I found it kind of amazing, this discovery that a user space implementation could actually be faster than a kernel space implementation, because of course if you go back several years before DPDK, people typically thought of user space as being a lot slower because it was typically going through a kernel interface to get those packets in and out. I guess I'm really happy that we have something that's super fast. I think that it's a little bit of a challenge, and it's going to become an increasing challenge to make sure that everything that's available in the kernel is also available in DPDK and vice versa. And I'm a little sad that we end up doing so much duplication of work and code duplication, and that's more or less necessary because of not just technology differences, but licensing differences.
Okay, thanks.
Did I answer your question?
Yes, absolutely, yeah. So, any questions from the audience?
When will a TCP stack with a preload library that binds to BSD sockets be implemented?
I didn't understand the question.
Could you repeat the question? It was a bit hard to hear up here.
When will a TCP stack with a preload library that binds to BSD sockets be available as a part of DPDK, or is that a never?
I'm not sure that's going to be part of a vSwitch. Yeah.
Okay, well, I've been put on the spot here by John to try and answer that one. Tomoya, please also feel free to jump in and be put on the spot too. I'm not sure that I can actually give an answer to that, except the fact that maybe. I mean, there are already a number of TCP stacks out there right now that are based on DPDK. And as I understand it, there's a couple of people who have already implemented preload libraries for socket intercept. We heard some stuff like that in the VPP talk earlier. I don't know if we want to get into the business of, let's say, picking just one TCP stack as well, because there are so many out there. I'm sure a few more will also appear and may even be good. But I really don't want to get into the question of just picking one out of all those. So my answer to that is I don't see one happening as part of the DPDK project itself, as in the main DPDK project repo, but there are others out there to use, would be my answer to that one. Tom, anything else you think, or any other tech board members, wherever they've disappeared to? Jaren or Hemant, any thoughts? And I hope that kind of answers your question.
Okay, thanks. So I think Ronnie is feeling a bit left out here. So what's your take on hardware offload in vSwitches? Do you think it's going to be a really good thing for user space?
Yes, I think as we can see, it can accelerate a lot. 50% or even 100% is something that's, I think, worth a lot. And it's backward compatible. I don't see any reason not to use that.
Okay, and I suppose what about the kind of the challenges around maybe control plane side of it, or debug and stats? Do you think they're all things that we can get to the same kind of level of I suppose functionality as software?
Yes, because it's not the same like when you're using SRIOV. The packets still go through the software. So you have visibility also. If you implement TCP dump, you will have it. All the debuggability is still there. The only thing that you accelerate the classification. So we can add, some in the future maybe to validate if you think that we have issues that the specific hardware is not doing the right job, or even to verify it's there, to double check that the classification is right. So, but I don't think that we will have issues because, as I said, because counters, so we can support counters also in the hardware for, like what we said, for the drop rules and everything. So I don't see any, the issue that's, we see from customer asking about SRV are not happening when you're using OVS with DPDK, because the packets are still done in the software. It's just kind of acceleration, so it's not like a totally different data path.
Sure. What about?
Yeah, I just have a question. So, what's your take about the number of flows, and how many you can offload to the hardware, and also if you add a new header or something for the classification itself? How is the hardware able to cope up with these changes?
So, at least the Mellanox hardware can support millions of rules. So, of course, we'll have some degradation because when you talk about millions of rules, it's also the hardware have some caching because a limit cache size, so you will see a degradation, but we still manage, and I'm talking about numbers that we having on the SRIOV implementation. So we're just also forwarding the traffic. So even that's with going to 64Ks flows in the hardware, and even more, we're still going to have about more than almost 20 million packets per second when we're talking about VXLAN offloads. So I think the software is not, the limitation is still the software, is not the hardware.
So I guess I'm just wondering about you guys. Are you guys looking at hardware offload into Lagopus?
I have. Yes, we already use CryptoDev for Lagopus router because Tomoya said that Lagopus router already supports now trying to integrate the IPsec packet processing, and yeah, we use CryptoDev. And also, yeah, we now there are no plan, but yeah, we're thinking about apply many hardware accelerator functions.
Question from Bruce.
Yep, I have a question. It was called out in John's talk yesterday, and I heard it called out in your talk earlier about debuggability being one of the pain points in DPDK. So, given that general topic, what is your wish list for improving debuggability in DPDK? Okay, I know logging was mentioned, and there has been some work already done in the later DPDK releases to make the logging dynamic, rather than having to do a rebuild, because we realize having a rebuild is a pain and not really feasible. So beyond that, what would be your wish list of things to improve debuggability of DPDK?
Sure. So apart from like logging type changes, I think it would be really nice to have some introspection into like the ethdev library and the individual PMDs, like some kind of standard framework where we could actually drill into the hardware a little bit that gives us like some real like useful debugging. I say that, I don't know what's like useful until I need it, right? But I know like one thing that was cool to see was like the pdump library get developed, because at least then we could actually start watching packets go through the system, which was better than what was there before, which was nothing. Yeah, logging improvements are good. Yeah.
Tracing, somebody asked here, would tracing be on a wish list?
We didn't catch that.
The question was from here, but it was, is tracing desirable? Like something similar maybe in VPP?
I'm a huge fan of tracing, but I don't know what kind of tracing you're suggesting.
To add same functionality that the kernel have, so some trace points in different parts of the DPDK. For example, I implemented that myself for solving a problem with KNI. I didn't have the time for sending a patch or things like that, but I think tracing is the best way of solving complex interactions between PMDs, vhost, and all of that. So
when you say tracing like that, do you mean something like perf or system tap, but for DPDK?
Not really. Just I don't think we need all what the kernel have, but we need that trace point infrastructure for enable them when you require that. And I think, for example, the having all the trace output is easy for us because we have huge pages, for example, that are going to help. And so
I think one of the reasons it's difficult to answer it is, like, from a developer standpoint, this is all in user space. I have the ability to like pthread attach and like start introspecting the code myself and introspecting data structures and setting breakpoints and doing all that. You don't have that as easily with the kernel. So from a developer standpoint, like debugging is, you know, it's nice to just be able to run a command or run something and like see a pop-up, but you know, at the end of the day, I can always just like dive in, disassemble a function, see what's going on, whatever. But I'm not going to ask a customer to do that. They're not, like, there's no way that a customer who's running this, you know, in their lab that has like 40,000 nodes and like, oh, one of them's got a problem. I can't ask them to like, oh yeah, just load up GDB and like GDB remote to it and like, let's see what's going on. So from that perspective, that's like when I think of debugging, that's what I really have in my mind.
You might have the ability to ask a customer for a core dump, though.
Okay. So I guess another one is, what new features, maybe you can point this one to Sameh, what new features would you like to see in DPDK that could be used in multiple vSwitches? I know one that you're going to suggest.
Yeah, so for my side, I'd like to have like as I pointed out in my slide, a new library to do a better flow classification on wildcards. Today we are doing an exact match with Coco Hash. We have an ACL library, but the ACL library in DPDK is, based on my trials, is not very fast in updating. So I'd like to tackle this problem and see how to have a better classification library in DPDK.
So, but is classification, is that a software development problem or is that a research problem? There's a lot of classification algorithms out there. On the OVS side, we think we've picked a algorithm that's in sort of a sweet spot for us, but we'd always like something better. It's not clear to me that that's really a matter of writing code, though.
Yeah, it's always a trade-off between update rate and lookup rate. So the OVS one, is a very good one based on tuple search. But what we are looking for is even one that has somewhere sweet spot between update rate and lookup rate, or even a family of classification algorithms, and then the user have to pick which one to use based on his workload.
Yeah, one of the places, sometimes people come to me and ask, what should I do research on? And I often point them recently to an idea of what I think of as a hybrid classifier, where you pair something that's fast but difficult to update with something that is slower but updates quickly, and see if you can hit something in the middle that achieves something better than either one of them. But nobody's actually come back to me with a proposed solution yet.
Another function I want is, sorry, I don't know whether the function have been supported or not, but Linux NAPI-like packet receiving mode. This means that interruption and polling modes are combined mode. Because one of the cons of the DPDK is power consumption. Yesterday's presentation shows that how do I say, changing the frequency to improve the performance, but NAPI approach also improves the performance, I think.
Yeah, so I think some of the DPDK PMDs have that implemented, that it can go into an interrupt mode. I think probably, if you look at the power example, it tries to do like less severe things first, like bring down the frequency scaling, before it will go back into interrupt mode. But I think certainly the potential, there's at least maybe 3 or 4 PMDs that have interrupt mode there, so that could be certainly something you could look at.
Yeah, question. Every year we have a new hash algorithm which is far better from the previous ones. Very wonderful. And my question is, we are supporting only some of them, not a few in DPDK. Does it help you to have more optimized implementation of this hash algorithm in DPDK?
I can't answer that.
So the last few generations of Intel CPUs, at least, have a CRC32 instruction that we've used for hashing in OVS. Do you have something that beats that in performance or quality, or both? I'm curious about the hash implementation you're talking about.
I think Tomas, you are talking about like the Coco hash and
yes, this kind of thing. murmur
okay,
and, you know,
so
triple X, this kind of thing.
So you're not talking about a hash algorithm, you're talking about a hash table data structure?
Yeah.
Okay.
Yeah, I guess there was some efforts a few years ago to try and look at the DPDK hash tables and see if they could be integrated into OVS, but I think there was maybe they just didn't really match right because maybe they were fixed length and and OVS needed a more variable length. But I guess that's the difficulty of trying to make a generic library for anything that everyone can use it, because an application itself can maybe tailor something more specifically to its use case and maybe get better performance. So and it would be similar, probably some mentioned with the ACL library, where there was nothing wrong with the implementation of the ACL library in DPDK, but it just it wasn't really suitable for the use case that was needed in OVS. So I guess we don't know if there's going to be a hash table that could be done by DPDK that would be generically used.
And since I also presented the membership library today, so for this new library that we pushed into 17.11, we submitted a patch in OVS to improve the lookup in OVS, and then it is under the review of the reviewers in OVS.
Any more questions from the floor? Okay, so I guess in terms of releases and the DPDK community, is there anything the DPDK community can do that would help help your vSwitches? Like for example, we talked about LTSs. Would you like to see more of them or less of them, or anything else really comes to mind?
Actually, I have a question not directly related to this one. Can I?
Yeah.
So I'm not sure. I mean, if DPDK community or developers has actually evaluated the performance of SSE memory copy, because if you look at the code, code is generated. I mean, if you look at the code, look at the generated code, that the RT mem copy is huge, and it's not even. Compiler wouldn't actually inline it. So if copy size is constant, then things are really, compiler will optimize a lot of code and it'll generate the compact code. But then let's say when you process packets, packet size is unknown, right? So what will happen is that it will code into this RT main copy, which is known in inline function, and with the code size is really big. We didn't have the time to compare with the normal memory copy versus this SSE memory copy. I wonder, look at the code size. Maybe in some cases, maybe just a normal memory copy might be better off with this compact code. So I don't know anyone can have any experience about, yeah. Because SSE memory copy assumes a lot of things like if and else and checking that the memory is aligned with some byte, and if so, then if it's not, then it will do all these kind of crazy things. So.
Unless anybody else wants to take that, I'll take that. So, yeah, I think we should evaluate that, because we had a patch in this release that was meant to improve that RTMM copy, and in fact, it decreased. The micro benchmarks were actually slower, and we had to revert that patch. I think maybe it might be worth re-evaluating that. Maybe we have that RT-mem copy for historical reasons, but certainly the standard mem copy has improved and gets optimized by Intel quite a lot actually. So it may be worth re-evaluating if that's actually worth our while maintaining and keeping in there. So.
So one thing that it's not that the DPDK community can do, but it is that the DPDK community is like talking about doing, and I think they're pursuing it. It's happening now. Is the Interop Lab, all this like additional testing stuff. That's actually really cool. I'm very happy to see that because that means like more hardware gets tested and all that. So we catch regressions earlier, we catch breakages earlier. That's actually like really good. I'm happy for that.
We have a question here.
Hi. I work in an OES team, OES DPDK team specifically. So the question I have is, each DPDK release, when it came out, and we have to do all this regression testing, and then probably we'll have some of the regression breakage as well. And then we have to report back and do it each time for each release, right? And now the release is pretty much in a very tight timeline. How, I mean, the panel is seeing to solve that, like to avoid this regression breakage and testing, to wait until the release date, or can we find it something before to make sure, to keep it in align with the OVS or vSwitch release along with the DPDK? Any suggestion for that? Because it's like...
Yeah, it's a good question. So, I mean, as you know, vsperf is potentially something that can be run on. You're talking about when you upgrade to new DPDK?
Yeah, so the vsperf, of course, it can handle some of the performance thing, but what about the functionality wise? So I don't think vsperf can cover the complete end-to-end case. So how do we handle that? Any suggestion?
Yeah, I mean, we have tests we would run in Red Hat. We would cover a lot of functionality, but they would be run by our QE team, prior to release. So,
is it on all the hardware platform or all the PMDs?
No.
So that means, still we may miss some of the regression cases, right? If you don't test all of them. Even we have the same problem. We don't have all the hardware platform or all the NICs for us to test it, because we have some of the Intel NICs. But
I mean, maybe something like the Interop, lab, maybe an additional one or as part of it. Maybe that's a place to, where at least all the hardware is there. And if vsperf is the best we have, then, I know it's been extended for some functionality. Maybe that's something we could look to do to try and put that as part of the lab.
I think we should need something in place to do that. It looks like, because the more PMDs are in DPDK and more hardware, and it seems like we need something in place to make sure when there are changes happening in those PMDs and in the DPDK, it's working fine, and at least in OVS DPDK,
So you could send everyone hardware.
Yeah, no, but you can send everyone hardware, starting by OPNA vPod, because OPNA vSperf project aim to characterize the vSwitch, so you guys. And as I said earlier in my talk, we use TestPMD to calibrate the bare metal, TestPMD as a vSwitch. And you can do that if you provide the hardware. We can test the whole matrix. Today we have few servers. If you send servers, NICs will be happy to run it and to look at the results. This is the goal of vSperf OPNAV. So we are going to have to catch regression, and at some point, I'd like to see how OPNAV can be leveraged by DPDK community, and how the result of the CI will be pushed back to DPDK saying, okay, we have a regression. So basically, you would have a CI outside of DPDK giving feedback to DPDK community. That would be great, but yeah.
I think in that case, every vendor has to agree that to give the hardware, then it's not just the Intel, I would say.
So that could have been an expensive question for you, Sagesh.
Yeah, of course, that's what I think.
Okay, I think we're almost out of time.
Yeah, if there's no final questions, we'll wrap it up there. And I'd just like to thank the panel. And thanks, Conole. And